Chapter 4, Exercise 4.109. The elemental mass percent composition of salicylic acid is 60.87% carbon, 4.38% hydrogen, and 34.75% oxygen. Determine the empirical formula of salicylic acid. Although we are not given the amount of this compound, salicylic acid, it's usually convenient to assume we have 100 grams of such compound, and then determine the number of moles of carbon, hydrogen, and oxygen, and then we determine its empirical formula. So first, let's assume the total mass is 100 grams, and then we have 60.87 grams of carbon, 4.38 grams of hydrogen, 34.75 grams of oxygen. And now let's compute the number of moles of carbon. 60.87 divided by the molar mass, we get 5.07. All right, 5.07 moles of carbon, or maybe 5.068. I'm gonna use one more sig figure. So carbon is 5.068, and let's use a larger font size. Okay, this is the number of moles of carbon in 100 grams of such compound. 4.38% hydrogen. So that means we have 4.38 grams hydrogen atoms in 100 grams of sample. And now the molar mass of hydrogen. So we got 4.345. Alright, finally oxygen. Oxygen 34.75. 34.75 divided by 16. 16 is the mass of oxygen in AMU, or gram per mole. We get 2.172. Alright, so now we have these three numbers. How do we determine the empirical formula? So one thing we can do is all three numbers can be divided by the same number, right? And then we have the same ratio. So what kind of number do we choose? Well, it's pretty easy. We find the smallest number over here, and we're going to divide all three numbers by that smallest number. So it's going to be this. Alright, and this is going to be divided by this. Alright, and this will be divided by the same number. So again, you first assume there's 100 grams of such compound, and based on the mass percentage, you can compute the number of moles for every single element. Alright, and we have these three numbers. Find the smallest number, which is 2.172 here, and then all three numbers divide by 2.172, the smallest number. Alright, so that you get a 1. This I believe it's 2, roughly 2. Okay, you can tell 4.34 is 2 times 2.17. Alright, this 5.068 divided by 2.172. Let's use Wolfram alpha. Alright, we'll get a number here, 2.333. Alright, we put this here, 2.333. Obviously you cannot have 2.333 atoms, right? So you can't just write, carbon 2.33 and the oxygen 2 and hydrogen or oxygen 1. You cannot do that. But you probably notice this 0.333 is 1/3. So if we multiply every single number by 3, we will be able to get integers. Alright, so if we do that, we get 7. If we multiply 2 by 3, we get 6. And over here, we'll get 3. So look, the ratio can be 7 carbon, 6 hydrogen atoms, and 3 oxygen atoms. So this times 3 is 7. This times 3 is 6. This times 3 is 3. It's going to be carbon 7, hydrogen 6, O7. Alright, let's see if mastering chemistry will be lenient about this. Probably not. Use subscripts. Alright, so I'll just use subscripts 6, and over here it should be 3. Alright, submit. You can see they pretty much used the same method as we did. They got carbon 2.33, hydrogen 2, oxygen 1, and then they also realized this should be multiplied by 3, and then they got the empirical formula.